again. Spooky season. Okay. The next question that we got on the menu. What is the formula for the sum of the first n terms in an arithmetic series? Let's rewind for a second, okay? Before we handle this question, what even is an arithmetic series? Or sequence, my bad. An arithmetic sequence is a set of numbers where there is every term is a little bit bigger than the previous term, but only by a certain amount. And the amount, like, you're always adding to it. So an example of an arithmetic sequence. Arithmetic sequence. An example would be 1, 2, 3, 4, on and on and on to like 57, 58, all the way up to, I don't know, however long you want to go. These arithmetic sequences can go on for a very long time if you want them to. But we don't always want them to because we're lazy mathematicians. But that doesn't mean we're dumb. That just means that we know that we don't necessarily want to put in effort to solve things if there's an easier way. So this is an example where we're adding by 1 each time. We could have other examples where we're adding by maybe 5 each time. So like 5, 10, 15, 20, 25, on and on and on. It's maybe like 1,000, 1,005. Like, we can go for forever, but you know, it gets less and less exciting every term. But this is typically what you want to pick up from arithmetic sequences, is that every term is a specific amount added to its previous term. Or if you're at a term, to get the next term, you're just adding by a certain amount. And that certain amount will be always the same everywhere in the sequence. Like, to go from this term, the 1,000 term, to the 1,005, we're adding 5. Same thing with all of the lower level terms, like the earlier terms in the sequence. Like, we're just adding 5 to find the next thing. Okay, now, how do we find the sum for the first n terms? Well, we could just add them up, but that doesn't seem like fun to type in a calculator, and if you press one button wrong on your calculator, you crash the whole boat. So you want to avoid doing delicate calculations like that where you're typing in a lot. Typically, you want to type in as little as possible into your calculator, because every time you push a button, there is a risk, a small risk, hopefully, but there is a non-zero risk that you'll push the wrong button and crash the whole boat. So a nice way to find the sum of the first couple terms in an arithmetic sequence, the sum of the first n terms, like, it could be the first 5 terms, it could be the first 5,000 terms. You know, it depends on what you're feeling on the calculation or what your application requires. So the sum of the first n terms in the, let's just call it the A sequence, the arithmetic. Arithmetic might sound like error, but we will not have any errors if we calculate it this way, as opposed to the the arithmetic errors that you see if you type it into the calculator. Yeah, don't want none of that. The sum of the first n terms is this equation. So it's the sum of the first n terms so we can represent that with the big S and a subscript n. S for sum, n for, you know, the n terms. That equation is just going to verify to make sure that I got this good. So it is the number of terms, n, divided by 2, or I'll write it out in full as like the words, and then I'll write them out as symbol. So this would be num of terms, divide that by 2, and multiply that by the first term plus the last term. Okay, so the number of terms is n. Let's actually rewrite this to be a little bit shorter. Equals n over 2, n being number of terms. Fairly straightforward. Multiply by the first term. That is simply, that depends on what your first term is, but I mean, if they give you an arithmetic sequence, you kind of got to know what your first term is. So that will be, let's call that A1. A1, so that's the first term. First term value should be given. Plus, how do we find the last term? Well, let's think about this for a second, okay? To go from term to term, we're adding by a certain amount every time. So to get the next term in like the low sequence here, or in the sequence here, to go from term to term, we're adding 5. Like we start at 5. That's our first term. Our second term is 5 plus 5. Our fifth term is going to be 5. Our initial term plus 4 times 5, so 20. Okay, so to calculate our last term, it will just be the first term. It will be the sum of the last term is going to be n minus 1 multiplied by d. N being the number of terms that we're taking an analysis of. It should be like 2 times first term. Yeah. I think it should be for 2 times first term. Let me double check this because I do not want to say nothing wrong and have anyone include that into their calculations. I think it is just first term, and the last term is n minus 1 times d. D being like what you're adding each time. Okay, I actually think it is 2 times the first term, but we'll run it through an example and we'll see if it works out. Okay, so let's do it for our first example here. So let's use this equation for, like, if our sequence is 1, 2, 3, 4, we know that n is equal to 4. We know that d is equal to 1. We're adding 1 to get to the next term. We would expect our sum. We're expecting our sum, our Sn, to be 1 plus 2 plus 3 plus 4. That's good. We're going to expect 10. And I guess our A1, our first term, is 1. Sounds about right. Whoa. Okay, let's run it through the equation and see if our equation is good. So S of n, we expect n divided by 2 multiplied by 2 times A1 plus n minus 1 d. Okay, S of n, our n is 4 over 2 times 2 multiplied by 1, because 1 is our first term, plus n minus 1, so that's 4 minus 1, and multiplied by d, that's just 1. Okay, so let's do some quick math. So we got 4 divided by 2, that's a solid 2. 2 times 1, that's going to be 2, plus 4 minus 1, that's 3. And then 3 times 1, you know, so looks like 3 to me. So we got this. Inside the brackets, 2 plus 3, that's 5. 5 times 2, 10. And that's exactly what we would expect. Okay, so this is the equation, or the formula that you should use if you're trying to find the first n terms of an arithmetic series. Now, you know, we can double check our expected value with like a small sequence like this, because it's fairly easy for us to like mentally add this up. But you might get some very spicy arithmetic sequences where, let's say, n is going to be 1,000. You can't necessarily trust yourself to be adding them all up unless you write a program to do that, but that's a whole nother thing. So use this equation instead. We just proved that it works good for 4 terms. I assume it definitely has to work good for 40 terms, 4,000 terms, you name it. Just make sure that you're able to extract your values here. So the n, that's just a number of terms. D, that's what you're increasing by to go from term to term. And A1, that's just the first thing the first element in the sequence that you're looking at. Sounds good. So D, I mean what you're adding from term to term, also known as the common difference. That was the vocabulary I was looking for. But yeah, you try this, you'll do good. It'll be a lot easier. Like, let's say you got 1,000 terms you want to add up. This is the way to go. You don't want to be manually doing that math. It takes too long. Sounds good. So the above solution is good.